Hello, welcome to another video on statistics, and I'm still dealing with the chi-squared test of independence, and this is question number 2. In lesson 3, I presented question number 1 on chi-squared test of independence, which is also known as the chi-squared test of contingency tables. Now question number 2 says, a survey is conducted on a group of 1,000 residents of city N across all age groups regarding their attitude towards saving. Below are the results of the survey. So we have age, and then we have 50 years and above, and then we have less than 50 but greater than or equal to 30. In other words, between 30 and 50, 30 inclusive, and less than 30 years. And these are the numbers here. Those that love saving, these are the numbers. And then total 315. Those that do not love saving, these are the numbers. And the total 330. Those that are undecided whether they love saving or not, these are the numbers, and that's the total. When you add horizontally, these are the totals, and when you add vertically, those are the totals. And when you add these three numbers, you get 1,000. Add these three numbers, you also get 1,000. Now, the question says here, at 5% level of significance, is there sufficient statistical evidence to infer that the love for saving is age dependent in city N? So remember, on chi-squared test of independence, we basically focus on two variables. Now in this case, we're talking about age and love for saving. So these are the two variables we're focusing on: love for saving and then age. So the question is saying, at 5% level of significance, is there sufficient statistical evidence to infer that the love for saving is age dependent? Does it depend on age in CTN or not? Right. So let's look at the solution then. We go through the 6 steps because this is hypothesis testing and chi-squared test of independence. Step number 1, we have to state the null and alternative hypothesis. So step 1, that's our answer or solution. For question number 2, step 1, we have to state the null and alternative hypothesis. So the null hypothesis, remember what I said in lesson 3, the previous video. I said for all chi-squared tests of independence, the null hypothesis should say the two variables are independent. In this case, which two variables are we talking about? Like I said earlier on, we're talking about age here, age and love for saving. These are the two variables we're focusing on. So the two variables are independent. That's our null hypothesis. Let us state the alternative hypothesis, H1. The two variables are dependent. These are the cases. These are the two hypotheses for chi-squared test of independence. The null hypothesis, the two variables are independent. The alternative hypothesis, the two variables are dependent. Step 1 completed. Let's move to step number 2. If you remember, in step number 2, I said this is where we state the alpha level or level of significance. In this case here, the question says at 5% level of significance. So our alpha value is 5%. So alpha is equal to 5%. And we all know that 5% is 0.05. That's the value of alpha. And in step number 2, if you remember, this is where we also determine what we call the degrees of freedom. The degrees of freedom, remember, for chi-squared test of independence, we focus on the number of rows minus 1, multiply this by the number of columns minus 1. So in this case, this is the table we have. How many rows do we have here? We have If you notice, I told you we remove that row for headings. We remove this column here, and we also remove that column. We remove this row here. So we have 1, 2, 3 rows. Columns, 1, 2, 3 columns. All right. So we have 3, 3. R equals 3, C equals 3. So this will be 3 minus 1 times 3 minus 1. And if you check this one here, is actually going to be equal to 2 times 2, and our answer is 4 degrees of freedom. That completes step number 2. Let's move now to step number 3. In step number 3, this is where we determine what we call the critical value. And what is the critical value? Is a value that separates the rejection region from the fail to reject region. So chi-squared in this case, crit for critical is going to be equal to chi-squared. We have to state the level of significance, which is 0.5, 0.05, and then the degrees of freedom, 4 degrees of freedom. And if you remember, this value is read off from the chi-squared distribution table. So here is the chi-squared distribution table. How do we read it? Like I said in the previous videos, we read this one as follows: 4 degrees of freedom on the left. Here we are, 4 degrees of freedom, and we must move to 0.05. There is the value 0.05 as the value of alpha, and therefore the critical value is 9.49. That's the critical value. Remember, degrees of freedom on the left, 4 degrees of freedom, and the alpha level is 0.05. So our critical value is going to be 9.49. Right, so that's our critical value, 9.49. So this is 9.49. That's our critical value right there. Right, next we move to step number 4. And in step number 4, I actually drew the table just to help us with time. In step number 4, we redraw this table here and then include what we call space for expected frequencies. So these are the observed frequencies: 100, love saving for the ages of 50 and above, and then 110 between 50 and 30, 30 inclusive, 115 below 30, 105 below 30. When you add these numbers up, obviously you get that. And also for do not love saving, these are the observed frequencies. Undecided, these are the observed frequencies, and therefore we need to work out the expected frequencies in that space, that space, that space. And moving across on the other side, we also need to work out these values here and so on up to there. The question is, how do we determine this? If you remember what I said in the previous video, what we do is in that space there, we go down to the total and we go across the total. We take the two totals, multiply them, and then divide it by the grand total there. So we're now going to say 315 for that space, 315 times 330 divided by 1000. So 315 times 330 divided by 1000. And my calculator says 103.95. So the answer there is 103.95. That is the expected frequency. Let's move down to that space. And I'm going to say I move down 315, move across 350. We multiply these two, divide by the grand total. So it's going to be 315 times 350 divided by 1000. And the answer is 110.25. So here I have 110.25, 110.25. And then I'm moving down into that space. I'm going to do the same procedure, 315 times 320 divided by 1000. So 315 times 320 divided by 1000. The answer on my calculator says 100.8. 100.8. We're done with the three spaces. We're coming to do not love saving. We have to do the same procedure. So for that space, it's going to be total, go down, total 330, move across 330, multiply the two, divide by the grand total. So it will be 330, 330 times 330 divided by 1000 My calculator says 108.9, so that will be 108.9. I'm moving on into that space. It's going to be 330 times 350 divided by 1000. So 330 times 350 divided by 1000. My calculator says 115.5. So here I have 115.5. And then I'm moving on into the last space there. For this column here, it's going to be 330 times 320 divided by 1000. So 330 times 320, and then I'm dividing this by 1000. My calculator says 105.6. Remember, this is a space, so it will be 330 down here, move across 320, and then divide by grand total 1000. So 330 times 320 over 1000, 105.6. So that is 105.6. Now moving on to the last column there. In that space, it will be 330 times 355 divided by 1000. So 330 times 355 divided by 1000. The answer is 117.15, 117.15. And then I'm moving on to that space. It will be 355 times 350 divided by 1000. 355 times 350 divided by 1000. My calculator says 124.25. 124.25. Right. Finally, down here, we have to say 355 times 320 over 1000. 355 times 320 divided by 1000. My calculator says 113.6. 355 times 320 over 1000. Let me do this again. 355 times 320 divided by 1000. My calculator says 113.6. So 113.6. Those are the expected frequencies. Now, after computing expected frequencies, you should remember that the formula for the test statistic is chi-squared stat is equal to the sum from I equals 1 up to k of O sub I minus E sub I, O squared all over E sub I. You must remember now that k is equal to the number of cells. Number of cells. Now I'm going to explain what the number of cells is. That's the value of k. So number of cells in this case, if I may use this color here, number of cells, please take note of this. We have, that will be our first cell. That will be our first cell. That's 1. The second cell is this one here, 2. The third cell is that one there, 3. And then we move across the other side, 4. And then 5, 6. And then we move across there, 7, 8, 9. So we have 9 cells. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the value of k. So k is 9. So it means we have to compute for that these two numbers, and so on up to there, 9 pairs basically. So now we're going to say, therefore, we can work out the test statistic now. Chi-squared stat is equal to, changing that formula a little bit, it will be the sum from I equals 1 up to 9, remember, of what? Of O sub I minus E sub I, O squared all over E sub I. Now, if I may start on the other side here, far left, just so that I'm able to accommodate as many of these values as possible. Starting from there, it will be observed 100 minus expected, 100 minus expected, which is 103.95, O squared all over 103.95. The first part done, I'm left with 8 plus I'm coming in that space now. It will be 110 minus 110.25 all squared over 110.25. So 110 minus 110.25 all squared divided by 110.25, and then plus coming down here 105 minus 100.8 all squared divided by 100.8. So 105 minus 100.8 all squared divided by expected 100.8, plus we're moving up to the top there now in the do not love saving column. 110 minus 108.9 all squared of 108.9. So that will be 110 minus 108.9 all squared all over 108.9. And then I'm going to say plus, we're moving into that space now. 130 minus 115.5, 130 minus 115.5 all squared divided by 115.5. And then plus, we are down here now, 90 minus 105, 90 minus 105, 0.6, 90 minus 105.6, all squared divided by 105.6. And then I say plus here, moving up to the top there now, we'll say 120 minus 117.15, all squared divided by 117.15, plus, I'm here now, 110 minus 124.25 all squared divided by 124.25, plus the last part now. We're here 125 minus 113.6 all squared divided by 113.6. So now these are quite a lot of calculations. One has to be extremely patient here in order to maintain the required level of accuracy. So I'm going to compute this, punch into the calculator. I'm going to do 1, 2, 3 at a time. So I have the first part here. It's this part. Let me move this one up so you're able to see. So I'm going to say, here we go, 100 minus 103.95 all squared divided by 103.95. Then I move across, plus, I'm here, and then I say 110 actually, 110 minus 110.25 all squared divided by 110.25, and then I say plus, there it's 105 minus 100.8 all squared, 105 minus 100.8 all squared over 100.8, and then I'm going to press the equal button and then carry on down here, plus, so it will be 110 minus 108 minus 108.9 all squared divided by 108.9, and then I move across, plus, I'm here now, 130 minus 115.5 all squared, 130 minus 115.5 all squared over 115.5, 115.5, and then I say plus, there I have 90 minus 105.6 all squared divided by 105.6, right? So that's 90 minus 105.6 all squared over 105.6. And then I'm going to press the equal button. And then I'm coming down here, the last part, which is going to be plus. And then I say 120. Hopefully you can see I'm now computing this part here, that part all the way up to there. 120. If I move this one up so they're able to see what I'm doing, I'm now on the last part. 120 minus 117.15 all squared divided by 117.15, and then I say plus there, 110 minus 124.25 all squared divided by 124.25, and then I say plus 110 minus 124.25, 124.25 all squared there at the top, and then plus on the last part. Now I'm saying 125 minus 113.6 all squared divided by 113.6, and if I check here, I've entered the numbers correctly. Yeah, it's squared. When I press the equal button, the answer is 7.3093 to 4 decimal places. So this is going to be 7.3093. That is our test statistic. Right. Step 4 completed. We're moving on to step 5, which is the decision rule step. Now, let me move this one here over here, and I'm coming to step 5. If I may move these pages down a little bit. Step 5. Step 5. If you remember, we call it the decision rule step. What does the decision rule say? It says reject the null hypothesis HO if the test statistic chi-squared stat is greater than the critical value chi-squared crit. If you remember, this is where we actually draw our sketch of the chi-squared distribution curve, like so. We have chi-squared here, and then we have f of chi-squared, and then, like I told you last time, the chi-squared curve is skewed to the right, like so. So what is our critical value? The critical value computed here, it is 9.49. We indicate this value first, and then we are going to indicate the test statistics. So let's say that this is our place here where we have 9.49. That means that is our rejection region area. That shaded area is your alpha, which is 0.05. If you remember in step 2, rejection region. And then the question is, this is our test statistic. What is our test statistic? 7.3093. Is this number bigger than or less than the critical value? You can see that that number is less. So it will be somewhere around here. This is where we're going to find the number 7.3093. So it is in the fail to reject region. Rejection region, fail to reject region, like I said in the previous videos. So let me just put it there. This is the fail to reject region, and obviously this is your rejection region. Now, where is our test statistic? It falls in the fail to reject region. So what is our decision? Our decision is, therefore, since the test statistic, this one here, chi-squared stat, is less than the critical value, chi-squared crit, we fail to reject HO. If we fail to reject the null hypothesis, it means we support the null hypothesis. And therefore, if we support the null hypothesis, we reject the what we call the alternative hypothesis. So if we fail to reject that, it means we support it, and therefore we reject this one. Let's look at step number 6, which is our last step. Step 6. Remember, this is where I said you have to write a comprehensive statement here answering this question here, which says, at 5% level of significance, is there sufficient statistical evidence to infer that the love for saving is age dependent? In other words, if you check here age dependent, it means basically is saying that question is saying, are the two variables dependent? Are the two variables dependent? And what did we find? We found that we failed to reject that. It means we support HO, and if we support HO, we are saying the two variables are independent. The two variables are independent, and therefore, our answer to this one is we don't have sufficient statistical evidence to infer that the two variables are age dependent, because the two variables are age independent. So our final step there is, therefore, at 5% level of significance, at 5% level of significance, we do not have sufficient statistical, at 5% level of significance, we do not have sufficient statistical evidence to infer respecting how the question has been phrased here. Do we have sufficient statistical evidence to infer that the love for saving is age dependent? We do not have sufficient statistical evidence to infer that the love for saving is age dependent. In other words, we do not support the alternative hypothesis because we support the null hypothesis. If we fail to reject null hypothesis, we support it, and therefore we reject the alternative hypothesis. So this is a statement here. At 5% level of significance, we do not have sufficient statistical evidence to infer that the love for saving is age dependent. The question is saying here, at 5% level of significance, is there sufficient statistical evidence to infer that the love for saving is age dependent in CTN? So if you like, you can complete here and say in CTN. Let me just clean this up a little bit. So we are basically saying we support the alternative, the null hypothesis, and therefore we reject the alternative hypothesis. Right, so this is where I would stop on this one. If you are new to this channel, please share these videos and support us. Share these videos with friends. Support us to grow the channel. It will allow us or give us the ability to be able to produce many more videos. By so doing, we will be helping some people that are struggling in statistics. Statistics has always been my passion. Maths, physics, chemistry, these areas have always been my passion. So remember, and I want to say this, remember, there is greatness in humility. I present these videos in the simplest way possible, using the simplest medium of instruction, I would call it English, and I speak it in a way that carries everyone on board. And the pace at which I'm covering these concepts, I want to believe that is good enough for everybody to follow. So, and I challenge Everyone who is doing statistics at the moment, second year statistics or first year statistics, statistical inference to be specific, watch these videos and go and attempt those exam questions or past exam questions and come back to me. You will agree with me that these videos are going a long way in helping you obtain a very serious distinction. All right, I'll see you in the next video.